Have you ever gazed up at the towering skyscrapers punctuating the skyline and wondered how they were built? The dawn of skyscrapers is an intriguing tale of human ingenuity and the quest to touch the sky. It all began in the bustling city of Chicago in the late 19th century. In 1885, a building like no other graced the city, the Home Insurance Building. This humble 10-story structure may not seem impressive by today's standards, but it was the first to use a revolutionary technology that would change the face of architecture: the steel frame. This innovative use of steel allowed buildings to rise higher than ever before. Previously, the weight of a building rested on its walls, limiting its height. But with the advent of the steel frame, the load was distributed across the structure, allowing it to soar to new heights. And so, the era of skyscrapers was born. Without the invention of the steel frame, the skyscrapers we marvel at today would not exist. As technology advanced, so did the height of the skyscrapers. The early 20th century saw an intense rivalry between Chicago and New York, each vying to claim the title of the city with the tallest skyscraper. Iconic structures like the Chrysler Building and the Empire State Building emerged from this high-altitude competition, forever changing the city skylines. What made these monumental structures possible, you ask? Well, it was a combination of advancements in elevator technology and innovative building materials. With the advent of faster and safer elevators, architects could now design buildings that soared to new heights. Meanwhile, the development of steel as a structural material provided the strength required to support these towering structures. This was more than just a competition between cities or architects, it was a race to the sky. A race that was pushing the boundaries of engineering and architecture, setting the stage for a future where the sky was no longer the limit. The race to the sky was heating up, pushing the boundaries of engineering and architecture. The title of the world's tallest building has changed hands many times over the years. But as of now, the crown belongs to the Burj Khalifa in Dubai, standing at a staggering 828 meters. But towering heights aren't achieved with bricks and mortar alone. The construction of the Burj Khalifa, for instance, required a revolutionary approach to structural engineering, using a buttressed core to support its immense height. Moving on to the second highest, we have the Shanghai Tower in China, reaching 632 meters into the sky. This skyscraper faced a unique challenge, being located in a typhoon-prone area. Engineers tackled this by designing a twisted structure that reduces wind load, a remarkable solution that combines aesthetics and functionality. The Abraj Al Bait Clock Tower in Mecca, Saudi Arabia, standing at 601 meters, is third on our list. Building this skyscraper was a balancing act, as engineers had to ensure it could withstand the desert heat while preserving the historical and religious significance of the location. A high-tech cooling system and meticulous architectural design were the ingenious solutions to these challenges. Next, we have the Ping An Finance Center in Shenzhen, China, that reaches 599 meters into the sky. This structure had to be incredibly robust to withstand the region's high seismic activity. The solution? A megamat foundation, a first in skyscraper construction, providing incredible stability. Lastly, the Lotte World Tower in Seoul, South Korea, stands at 554 meters. Its challenge was to resist high winds and earthquakes, and the solution was a tuned mass damper, a giant pendulum that counteracts movement and keeps the building steady. Each of these skyscrapers is a testament to human ingenuity and the incredible feats of engineering we are capable of. They are not just buildings, they are symbols of our determination to reach higher, to challenge the impossible, and to continually push the boundaries of what we can achieve. As we look to the future, the question is not, how high can we build, but how should we build? The future of skyscraper construction is not just about touching the clouds, but about redefining the blueprint of sustainable living. We are moving away from the age-old practice of bigger is better to a more conscious era where smarter is superior. The buzzwords of the future are sustainability and renewable materials. Buildings will need to be more than just structures. They will have to be ecosystems, self-sustaining and carbon neutral, if not carbon negative. Imagine skyscrapers made of timber, a renewable resource, sequestering carbon and contributing to the cooling of our cities. But the innovation doesn't stop at materials. The skyscrapers of tomorrow will serve multiple purposes. They will become vertical cities, hosting residential spaces, offices, and even farms. Yes, you heard right, farms. Vertical farming in skyscrapers could revolutionize our food system, making it more local, more sustainable, and more resilient to climate change. Residential skyscrapers, too, are a part of this vision. They will be more than just homes in the sky. They will be communities complete with parks, shops, and schools, promoting a sense of belonging among residents. The skyscrapers of the future will not only redefine our skylines but also how we live, work, and interact with our environment. The future is here and it's looking up, literally. From the humble beginnings of the home insurance building to the dizzying heights of the Burj Khalifa, skyscrapers have come a long way. These towering structures are more than just buildings. They are a testament to human ambition, creativity, and the relentless pursuit of reaching ever higher. The evolution of skyscrapers is a captivating story of technological progress. From the first use of steel frames that allowed buildings to soar beyond 10 stories, to the advent of high-speed elevators making the uppermost floors accessible, every innovation has pushed the boundaries of what's possible. The construction of these giants is an engineering marvel in itself. It's not just about stacking floors on top of each other, it's about creating a self-supporting structure that can withstand the forces of nature, from high winds to earthquakes. It's about integrating complex systems for electricity, plumbing, and ventilation. And it's about doing all this while ensuring the safety and comfort of the thousands of people who live and work in these buildings every day. Looking ahead, the future of skyscrapers is as exciting as their past. With advancements in materials science, digital design, and sustainable practices, we can expect to see taller, more efficient, and more awe-inspiring structures in the years to come. Next time you look up at a skyscraper, we hope you'll see not just a building but a monument to human ingenuity and the incredible feats of engineering we are capable of.